Alright, this is 6.6 polynomial rational inequalities. So instead of an equal sign, we're going to have a greater than or a less than, greater than or equal to, less than or equal to symbol. And this first slide I'm just showing you basically like the 5-step process to solve these things. So for a polynomial inequality, you want to take whatever you're given and get everything to one side and 0 on the other. And then we'll call that whatever's on the side opposite the 0, we'll call that f of x. And then you're just going to treat it, even though it's an inequality, you're going to treat it as if it's equal to 0. That's what we got here in step 2. Treat it as if it's equal to 0. And then solve that using the techniques that we've talked about in the last couple sections. Polynomial equal to 0. And then step 3 is a little bit different than what we've been seeing. You're going to create what we call a sign diagram, using those zeros from step 2 to separate your domain. You're going to take your domain and cut it up at these zeros, and it's going to create all these regions. And then you're going to pick, step 4 says you're going to pick a test value from each region and come up with a sign. Just, is it a positive output or negative output in that region? And then everything comes down to what order symbol you originally have in the problem. If it's greater than or equal to, you're going to end up choosing, your answer is going to be the plus regions. Bracket if it's an order equal to, parentheses if it's strictly greater than, and then if it's a less than or equal to, you're going to look for the minus regions. And again, bracket if it's a less than or equal to, parentheses if it's strictly less than. Alright, and then the same thing basically for a rational inequality, only we have an extra step in there, or like extra part in there. Actually it is a step. I just now realized that I didn't change this to 4, 5, and 6. That should be 4, 5, and 6. So it's basically the same thing you did before in for polynomials, but the thing that's different is, first of all, you need to possibly get common denominators when you group everything to one side. And the other thing is, after you've set it equal to 0 and solved what makes it equal to 0, you also need to come up with what makes the denominator equal to 0. And both of those things is what you're going to use to carve up your regions. Alright, but everything else beyond that is the same. So the extra step was getting common denominators, and then also including what makes the denominator 0 rather than just the polynomial, or the numerator, in this case 0. So let me just walk you through a couple of these and show you it's not as bad as it may seem to be. Alright, so here's a polynomial. It's already set greater than to 0, but you know, hypothetically had, let's say for instance, had, you know, this piece been over here, we would just group everything to one side greater than 0. Alright, now what I want to do here is treat this as if it's equal to 0. Alright, everything already is to one side, so I'm already down in these steps. Alright, I'm already down to step 2 because everything's on one side. So I'm going to treat it as if it were equal to 0 temporarily. So 144x minus 48x squared plus 4x cubed. I want to treat it as if it's equal to 0 and solve this. Now GCF here, there's an x in all of them. I'm going to pull that out, but also everything here is divisible by 4, so I'm going to pull a 4x out with it. Alright, 4 goes into 144, 36 times, minus 48 divided by 4 is 12, and then x squared divided by x is x. Alright, and then obviously 4 divided by 4 is 1, and then x cubed divided by x is x squared. Alright, and then try to factor this. If you need to, you can rearrange it to go in descending order, so x squared minus 12x plus 36. If that helps you, then do it. Rewrite it in descending order, so you can factor it properly. Alright, if you can factor it from the original form, do that as well. It's important to be accurate. Don't worry about skipping steps or extra steps. Just be accurate. Alright, two numbers that multiply to negative, two negative numbers that multiply to 36 and add to negative 12. Alright, that's going to be 6 and 6. Alright, negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. Alright, and so we end up with 4x is equal to 0 or x equals 0 and x equals 6. Okay, we don't have to do it more than once. Alright, it shows up twice, we don't have to do it once. So these are where we're going to divide the domain. So there's our number line. What I always do when I'm doing these polynomial inequalities is I label the left side negative infinity, the right side positive infinity. Alright, and just make sure you got it accurate. There's 0, there's 6. Okay, so there's three regions we have here. Alright, we got from negative infinity to 0, comma 0, and again there's no or equal to, so I'm using parentheses. Alright, then there's from 0 to 6. Alright, and then there's from 6 to infinity. So there's the three regions that are created by these things. Now, I'm going to pick, these are regions, I'm going to pick a test value that's in each region. And then I'm going to determine the sign. So something that falls in here between negative infinity and 0, I'm going to pick negative 1. Alright, something in here between 0 and 6, I'll pick positive 1. And then something on the other side of 6, like 7. Alright, and then we're going to determine what the sign is. Alright, so in this region, when I pick negative 1 for x, alright, negative 1 times 4 is negative 4. Alright, so I got a negative times negative 1 minus 6 is negative 7. A negative times a negative times, again, negative 1 times negative 6 is negative 7. Or minus negative 6 is negative 7. So I get a negative times a negative times a negative, which is a negative. Alright, negative times a negative is positive. Positive times a negative is negative. Alright, and then from 0 to 6, if I put 1 in there, 4 times 1 is 4, which is positive. Positive. Alright, and then 1 minus 6 is negative 5, so positive times negative times. And then again, 1 minus 6 is another negative 5, so negative. Positive times negative is positive. Alright, and then 7, if I plug in 7, 7 times 4 is 28, which is positive. And then 7 minus 6 is 1, which is positive. Times 7 minus 6 again is 1, which is positive. And positive times positive times positive is positive. Alright, and what are we looking for? We're looking for greater than 0. Alright, the numbers that are greater than 0 are positive numbers, so we're looking for the positive numbers. So that means there's a positive, so there's part of our solution. And there's a positive. So there's another part of our solution. Alright, and so our overall solution, is 0, 6, union 6 to infinity. Alright, make sure you break it up because 6 makes it equal to 0, and this is strictly greater than 0, so 6 can't be included. So
to make sure that you're paying attention to that kind of stuff. Alright, and then here's one that's a rational function, a rational inequality. So there's our average cost function, and we want to find something. What should x be to keep our average cost at most 590 per TV? So at most is a less than or equal to. Alright, so there's our equation. 5,000 plus 80x plus x squared all over x is less than or equal to 590. Now, what you don't want to do here is treat this like a rational equation and multiply through by the LCD. Okay, if you look at these steps, set one side of the inequality to 0, right, and if necessary get common denominators on the non-zero side. It didn't say anything about multiplying both sides to clear fractions. So we're going to subtract 590 from both sides. Alright, got a 0 on this right side. But what did the other thing say? If necessary, get a common denominator. And it is necessary because we're subtracting, and what's already there has x as the denominator. This 590 does not have an x as the denominator, so we do need a common denominator. Alright, so the common denominator obviously is going to be x because there's no other denominator. Alright, so there's what was already there. We're going to subtract, we're going to multiply top and bottom by x. Alright, and that way we've got 5,000 plus, now I can combine these two. 5,000 minus, alright, 80x minus 590x is minus 510x plus x squared all over x. Alright, that's less than or equal to 0. Now, once you've got it combined like this and simplified, this is when you determine what makes both the top and bottom equal to 0. Okay, in these directions, for a rational inequality, create a sign diagram using the zeros, set that equal to 0, and anything that will make the denominator from step 2 equal to 0. Alright, so we need to come up with what makes the function itself equal to 0. That's the top. Right, that's what makes the top equal 0. And then we also need to remember the 0 for the bottom. Alright, so let's set the top, and again I'm rewriting in descending order. So x squared minus 510x plus 5,000 equal to 0. And again, I'm going to need two negative numbers. Alright, and it's going to be minus 500 and minus 10. So x equals 500, or x equals 10. So far, that's all we have to divide up our domain, but we've got to always remember the denominator. What makes the denominator equal to 0? Well, the denominator is x, so obviously 0 makes x equal to 0. So these three things, these are the ones that make the top equal to 0, and this is what makes the bottom equal to 0. So this is where we're going to divide our domain up this time. Alright, so again, negative infinity, positive infinity. Alright, and this time we'll do 0, 10, and 500. Okay, we don't have to make it to scale. We're just coming up with our regions.
So what are our regions? We got negative infinity to 0 again. Alright, we've got from 0 to 10. We've got from 10 to 500. Alright, and then we've got from 500 on, so 500 to infinity. Alright, we're going to pick a test point in each one of those regions, and then we're going to come up with what's the sign of that test point. Now, I didn't show you this last time just because it was pretty straightforward how to do it, but with this one, I'm going to show you how you can use your calculator to help you. So, go to your y equals and put this in your calculator. Alright, so I've got that in there, and then this time go to your table set, which is second window, and then come down to independent and switch that to ask. Okay, and now when you go to second table, it's blank, and we can put in whatever we want to. So I'm going to come down and pick a test point in each one of these regions. So again, I'll use -1 in this region. From 0 to 10, I'll use +1. 10 to 500, I'll use 20. And 500 to infinity, I'll use 1,000. Okay, I could pick any number in those. I just chose those for whatever reason. Alright, now, -1, hit enter. I get a negative sign. Alright, +1, hit enter. I get a positive. Alright, +20, hit enter. I get a negative. Alright, and then +1,000. Plugging that in gives me positive. And we're looking for less than or equal to. So that's the negatives. Now, I made a little mistake here. That's less than or equal to. So that should be brackets on everything except the 0, or division by 0 occurred. So let me fix that really quick. So that's a bracket. Again, I don't put a bracket on 0 because 0 causes division by 0 and you can't divide by 0. Okay, but I put a bracket on the other ones because this time 0 is not off limits. So a bracket, pen, bracket at 10, bracket at 500. Alright, and we want the negatives. So here's a negative, here's a negative. So we want this region, and we want this region. Okay, they're the things that make this thing negative. Now, this is average cost function, where X is the number of hundreds of units sold. Okay, so this region doesn't make any sense. From negative infinity to 0, that means we're making a negative number of items. Alright, so that doesn't make any sense. So this is our answer. Alright, so to keep our cost at most $590 per TV, we have to set production. make sure it's not in hundreds or anything. Yeah, hundreds of units sold. So we must set production between 1000, which is 1,000, and 500, which is 50,000. Alright, so just always make sure to go back and check your units. And when you're solving these things, you got to make sure, check your domain. Right? What makes sense in the problem, and always throw those things out that don't make sense when you're doing an applied problem.